All right, class, welcome to another module here, module 5. And we're today gonna, or this week, gonna look at choropleth mapping, use a little bit of GIS. This is where it gets actually really cool and fun. And again, I know this class is it goes quickly, and so it's not giving you the chance to really dive into this. But I hope this at least for some of you maybe piques your interest a little bit. And if any of you are interested in diving more into this, do reach out to me. I do a lot of this stuff, and I find these tools to be very powerful, and they're applicable in so many different fields. And so many of you, depending on your career, many of you in very divergent directions and careers might be able to use this stuff. It's also quite lucrative. These are good skills for your CV. But firstly, in this video, I just want to talk about two key concepts, and that this is going to provide a little bit of foundation for us to talk about the rest of these concepts. So these two key concepts are, firstly, the modifiable areal unit problem, or MAUP, and secondly, the other concept is the choropleth map. It's a type of map. So I'll share my screen. I'm going to show you just a couple Wikipedia pages here. I know that Wikipedia has this reputation, this bad reputation in academia, maybe in high school as well. But also, for writing your term papers, professors tend not to accept Wikipedia as a proper citation. However, I think Wikipedia is a really valuable resource. I'm going to be using it just right now to show you some stuff, but I do think it's actually a really reliable source of information. So just a little side note and pro tip: if any of you ever want to use Wikipedia in future term papers for your courses, I would recommend just looking at the Wikipedia page and finding the sources that the Wikipedia page is citing, and go to those sources and cite those sources, right? So rather than citing the Wikipedia page itself, use the Wikipedia page as a gateway to find proper sources. I think that might work well for some of you. So let's share my screen here and take a look at these Wikipedia pages. So firstly, like I said, actually, let's look at the choropleth map first. So firstly, the choropleth map, it's a type of map that essentially it represents different colors for different aerial units. And you can see in this example, this picture of Australia, this map of Australia, you can see that happening. I want to scroll down and just show you this map as an example. So here's a key example of a world map represented in choropleth map form. You can see that each country in this map is represented as a different color, and each color spans that entire country. So it's not like there's a sort of spectrum of colors within a country. No, each country has just one solid color. And so this holds the same for any choropleth map. Whatever aerial unit we're talking about, whether it's the county level, the police district level, any sort of jurisdictional unit, each one is going to get a different color, but each unit will get that solid treatment of that one color, right? And so each color represents a different value. In this case, the values are mean wealth per adult, so basically the average wealth per adult back in 2018 per country, right? And the United States, oh, okay, yeah, the United States, it looks like it's falling between 250,000 and 500,000, which to me sounds actually really high. I think the United States, there are a lot of poor people in the United States, and there's a lot of social inequality in the United States, but I think the extreme wealth and the number of billionaires that we have in the United States is kind of dragging that number upwards. And also, we're talking about wealth and not income. And so when we're talking about wealth, we're talking about someone's assets, their home value, cars, all of those assets that they have, trust funds, savings. So of course, I can see how that might also skew this higher than if we were talking about income, but that's besides the point. I just want to show this as an example of a choropleth map. And so let's take a look at this problem that we call the modifiable aerial unit problem. And I'm just going to bring up this photo here. And this photo, this diagram rather, it shows the sort of gist of this problem. And so this problem happens when we use point data. So let's pretend that right here, these points represent COVID tests, and 0 means negative COVID tests, and 1s mean positive COVID tests. And so let's say that we get 3 measurements or 3 COVID tests in different areas on a map. And this one is positive, and then these 2 are negative. So if we were to draw an area, let's say, let's break this down, and this is like a county line right here. And so on this side of the county line, we've got that 0 and this 1, and on this side, we've got the 0, right? And so if we were to aggregate those, that would give an illness rate of 50% down here in this county and 0% over here in this county. But let's say we were to take the exact same COVID events or COVID tests, and let's say they were in the same places on the map, but the county got redrawn. And so the county now, the county line looks like this. So then that would change it to this county over here being a 100% illness rate, and then over here being a 0% rate. And nothing changed between this and this except for the political boundary. The actual COVID events on the ground are the same, right? And so this is a problem, as you might start imagining, right? Because a choropleth map can tell you very, very different things depending on how the boundaries are drawn and depending on what units are being used, right? So that's the modifiable aerial unit problem. And so we'll talk about ways around that, but it's just key to understand these 2 things: the choropleth map and the one of the examples of what could go wrong with choropleth maps, or an example of how choropleth maps can in some cases be inaccurate, the modifiable aerial unit problem. And so that's it for this example.